Good morning, good afternoon, good evening, Spanker here again. Episode 4, is it? 4 for Arduino. So last episode we spoke about could we get this potentiometer and this LED, this potentiometer to control this LED. And I don't know if you can see there, as I turn this it goes bright and goes dim. And it's going through the Arduino board, but what we also wanted to do is to, it's hard to see, but it is gradually getting brighter and then gets dimmer. Oh, something's gone tits up. There we go. Puts to full brightness and dims down. So what we've done is we've cannibalized the analog input code and the what was the other one called? Oh, I can't remember what it was called, the example. Digital read serial and the examples, and we've come up with this piece of code here. So I haven't commented it, I've just took a blank one and we've jumped it in. So what have we done? In fact, if I just show you this as well, in the serial monitor, we are getting a read of what value that LED is at. So it's at 70. As I turn that, it goes up to 255 and it gives us a read. So we're not only controlling the LED, we're actually able to read how bright it is as well. So we can read that in and adjust it and turn it, because like I said in the last video, it's easy just to get a potentiometer to control the brightness of an LED, but using the Arduino board we are actually be able to physically see what numbers coming out of that as well. So how do we do that? In that code is first line here, int LED out is 9. So that's saying that wherever it refers to LED out, it's number 9. And then in the setup code I've put the serial begin at 9600. That enables the serial port on the Arduino board to read into the PC. And then the pin mode, LED out, I've set to output. So I've told it that I want whatever pin I put on this integer, I want it to be an output. So that's stolen from that first piece of code. And then here, put your main code, that's just the, I could actually delete that. So I've put an integer of sensor value. This is stolen from the other code as well. Analog read is A0. So that's A0 is where our potentiometer is reading into. Now because the potentiometer reads 1024 steps and the output is only 256 steps, I then put an out value integer here. So the sensor value reads that pin and it gives us a number between 0 and 1023. I want the out value to be the sensor value divided by 4, because that's the only number I can output up to 255. I put a line of code in here to say print what that out value is. So that sends that to the serial monitor so we can view what is being put out on that pin number 9. Analog write, if you remember that one, analog write sends that number, whatever number we want, to LED out, which is pin 9. Analog write to pin 9, put the out value, which is the sensor value divided by 4, and then just delay 30 milliseconds just to make it stable so it's not pinging up and down. And that is the code for doing it. So I've cannibalized 2 bits of code, created this variable of out value myself, which is the sensor value divided by 4, just to pop that out so we get the LED controlled by the potentiometer and being able to read it in the serial monitor or in the serial plotter. Oh, it won't let me run the serial plotter because the serial monitor is already running. So let's get the serial plotter up. So that's just me twiddling that potentiometer and it's showing me visually what brightness the LED is at, and I can see the LED dimming and brightening as I do that. So because the last video was very long, we're going to do one more, pop back to the examples and have a look at one more example, I think. So we'll close that down. We'll go to our examples, basics again, and this one is called read analog voltage. So let's pull that up and see what that says. So this is going back to a potentiometer on pin 0. It gives a graphical representation using a serial plotter, and it converts it to a voltage. So rather than have a number between 0 and 255, it gives us a voltage that's been put out. Code's very similar, begins as serial communications, and then it puts an integer. Sensor value is analog read 0, it's exactly the same as before, and convert the analog reading, which goes from 0 to 1023, to a voltage 0 to 5 volts. So then it's given us another little function here called float. We'll go back to that in a sec. Float voltage equals sensor value times 5 divided by 1023. So that essentially does, that little algorithm there, is it does 5 divided by 1023, which converts, which tells it how many steps, what voltage equates to one step, and then multiplies it by the sensor value. So if you've got 1023 steps, it will equal 5, and then it just prints it out to the serial monitor. I haven't uploaded the code yet, so I can't look at that. A float is very similar to an integer, except you can use decimal numbers. So it's a floating point number. Integers, you can't usually use decimals. Floats are exactly the same, but it gives us a decimal value, which we want when we're reading a voltage. Print out the voltage that you read. So let's upload that code. And while that's uploading, I'll disconnect the LED setup we had, because that's not going to be used. So what we have now on the board is the potentiometer connected exactly how it was for the read, and we'll just pull up the serial monitor. Serial monitor boots up, so it's telling me there that we're running 2.15 volts out of into the pin. So as I adjust that down, it's going 0. I adjust it up, it should go to 5, and it's going to exactly 5. So what this is enabling me to do is we've created a voltmeter as such, albeit coming off the Arduino board, the 5 volts coming off and into there. It's telling me out what, because we're using a potentiometer to change that voltage, it's giving me an accurate measure of what it's reading. As I twiddle that, it seems fairly stable, and there's no delay, there's no in that code there is no delay set in it either. Wonder why that is. It's probably because we've only got 500. We've only got literally half the steps, haven't we? Half the numbers from 0 to 5, 0.00 to 5.00 is 500 different numbers we could have on there, where we originally had 1023. So that's it. That's the next circuit on the basics. What we're going to be doing next time, we'll make this video a little bit shorter. As analog read serial, we've done read analog voltage, we've done the fade, we've done the blink, bare minimum's just a blank one. Analog read serial, what does that one do? Have I got that one? I think we've already done that one as well. Have we? Analog read serial, there we go. What does this one do? Yeah, we've done that one. Digital read serial we haven't done, have we? If I went to examples and digital read serial, we're not going to do this one, because what this one does is read your digital input on pin 2, prints results to the serial monitor. So what that one's doing is activating a push button and reading it. It's very, very simple. It just reads an on and off and tells us the state of it. We're going to look at something a bit more exotic. We'll look at some of the digital things, I think. I've got a speaker handy, I might be able to do some of the tones. Some interesting things there. But we'll get through that in the next video. So this one's a little bit shorter. And I'll see you next time. Spanker out.